Thank you very much, everyone, for joining me today. My name's Bob Walker. I'm a field CTO at Octopus Deploy, and I'm really excited to be here to talk to you about progressive delivery strategies. Now, before I jump into that, if you'd like to get in touch with me, you can see all of my contact information below. I'll also have all this contact information on my very last slide, so if you don't get a screenshot of it very fast, don't worry. You'll notice that on that screen, I've been with Octopus Deploy since 2018. And prior to joining Octopus Deploy, I, in fact, was a developer. I started off as a developer working at Sandhills, where my job was converting classic ASP pages to ASP.NET web applications because of this brand new thing that had just been released by Microsoft called .NET, if that was to age myself a little bit. And since that time, my career has progressed. I went from a junior developer to what I like to call a seasoned developer, someone who's been around the block a couple of times, as well as a senior developer, a lead developer, architect, principal architect, and now I'm in my role that you see today. And over my many years of being a developer, I have done a lot of different deployments, and I've seen what's worked and what hasn't worked. In addition, working on Octopus Deploy, I've also had a chance to talk to customers, as well as do some internal reflection on what's working, what's not working. And to be honest, I've kind of come to the conclusion that when you start talking about progressive delivery strategies, specifically Canary deployments, I know that they exist. I do, but they're exceptionally rare. Almost no one does them. And I purposely put up some pictures of Bigfoot and Loch Ness Monster just because when I was talking about this with somebody else a couple days ago, they said, "Gosh, it's just like seeing Bigfoot in the wild when you see someone doing an actual Canary deployment to production." But I can see why they're so appealing because it's very tempting to have a magic wand that allows you to deploy and revert if something goes wrong. Preferably, in an ideal world, you can get back to a known good state that minimizes user impact. And in the true ideal world, you get in a situation where no one even noticed that something went wrong. So that's where Canary deployments really come into play. And again, this is very, very appealing because you have a new version of your code that you push out there and then use something like a load balancer that will then redirect a percentage of your traffic to that new version. But this is where I think Canary deployments start to fall flat. And this is where situations where when you really start scratching the surface, you end up in a situation where, excuse me, where you're not really thinking through all of the different possibilities. And a lot of questions come up. And I ask the same questions, especially when someone's looking at doing Canary deployments for the first time, such as what are the user requirements? And we'll get into what this means in just a couple minutes, but I just want to provide a high-level overview of some of the questions that come up. Not only what are the user requirements, but also does the application host that you're running on support progressive delivery, like a Canary deployment? Does the application architecture support running multiple versions in production? And if you haven't tested this, the answer is going to be no, because there's a lot of work you have to do on the back end for this to happen. And then finally, indiscriminately routing a percentage of traffic doesn't work for all use cases. It certainly works for some use cases, and I've seen it be successful. But at the same time, it's not something that you can do all of the time for every single application type or every single possible use case. So for this session today, I want to talk about successful progressive delivery strategies that you can implement using both Octopus Deploy as well as another tool such as Open Feature that allows you to get everything that you need. So first up, I want to talk about user and business requirements and why those are so important. Then I'm going to talk a little bit about why Canary deployments, in the traditional sense, they don't satisfy all of the user and business requirements and the challenges that you'll face. Then I'm going to talk about progressive strategies. And then finally, I'm going to wrap it up with some process changes that you can make. So let's first dive into the user and business requirements. I want to start off by saying that user requirements are not deployment strategies. And when I refer to users, I'm referring to end users, the people that are actually using your application. In all of the applications that I've worked on and all the deployments I've done, I've never ever had an end user come up to me that said, "I want you to deliver changes to me in a blue-green way or using a Canary deployment." That's never ever happened. But we need to consider the user requirements because they're at the bottom of the hierarchy of considerations when it comes to coming together with a deployment strategy. Because user requirements, they'll turn into business requirements. And some user requirements, they'll turn into industry regulations or even laws that you have to consider. But then there are a whole host of other things we need to consider before we start talking about a deployment strategy. So I'm not going to read this entire slide to you because it's a bit of a word salad, but I think the big thing is to take away from this is that, we have user requirements such as, say, uptime. But uptime can be defined in different ways, and it depends on the application that you're running. So, for example, if you work for a online bank, well, there's the expectation that the online bank is up 24 hours a day, most of the time, Monday through Saturday. One of the online banks I've done business with, they'll do their deployments starting at 12 a.m. Sunday morning. But compare that to with, say, something like a retail store that's deploying at a point of sale machines. Those have to be online while the retail store is open. And some retail stores, maybe they're only open from 8 a.m. to 9 p.m. Well, then at that particular point in time, then they don't have to have 24-hour uptime. So really, uptime matters during critical operating hours. But then conversely, once you have it uptime, then you also have to worry about deploying changes. And what does that look like from the user experience? Going back to the point of sale machines, imagine that you worked for some sort of retail store and you're working on during uh, the holiday season and you have a whole line of customers. The last thing that you want is for the application to change on you. Imagine a deployment occurs and you get a new user interface or some new buttons appear, some new functionality happens. You don't want that in the middle of your day. What you want is you want some training, you want some notifications, you want a chance to be prepared. You don't want it when there's a whole line of customers that can impact the business. But at the same time, you're also going to have power users who want to have the capability to provide feedback on any new sort of functionality. And so, from a business point of view, what they're looking for is more along the lines of having no unexpected functionality changes to their users during normal operating hours, but also provide the ability to access new functionality. And when new functionality is released, you want to make sure that it works as expected. Going back to the point of sale machine, or even the online bank, when you're working on an online bank, going with an online bank, you're expecting that you can see your balances, you can pay your bills, you can do anything along those lines. And if new functionality were to break, you want to have the ability to ideally disable it or revert to a known good state. So again, what the user expects translates into what the business expects, which can impact how you deploy your software. So now that we've covered that, let's talk a little bit about some challenges of Canary deployments. Now, Canary deployments, they're appropriate for a subset of use cases. They're not appropriate for all use cases that are out there. So I'm going to talk about some appropriate use cases first. Let's first talk transactional. This is when situations where sessions don't matter. So imagine that you're working on, say, an AWS Lambda, and it's dropping messages into a queue. And then you have another process that picks messages off the queue. If you were to change that, you would say, okay, 10% of all messages are processed by the older version, and then, or 90% are processed by the older version, 10% are processed by the newer version. That's perfectly fine. No one's really going to notice the difference. Now, in terms of a transactional application that might have a user interface, consider Google. Now, when you do a search, you get the results back. You can click through until you find what you're looking for. But if you were to do the same search, say 20 minutes later, you might get a completely separate set of results. This could be because under the covers, Google's gone through and they've changed how their indexes work, or they've changed some sort of business logic. And so there's almost this expectation of every time you do a Google search, you might get completely different results. But another appropriate use case is when you are moving or upgrading your application hosts. So internally at Octopus Deploy, when we want to upgrade our Kubernetes cluster for Octopus Cloud, we don't do in-place upgrades. What we do instead is we spin up an entirely new cluster with the version that we want to upgrade to. And then during the customer's maintenance window, we'll move the instances over to the new version. And so it's the exact same version of the instance. And so from a customer's point of view, it's very, very seamless. But we're doing this one customer or a couple customers at a time. We're not doing everyone all at once because, again, we have to respect the maintenance windows. Or if you're upgrading, say, from Windows 2019 to 2022 or something like that, you have a new version of your operating system, where you spin up the exact same version on the new application host, that new version, and then maybe you route 5% of the traffic over. I want to talk about another case that I was involved with when it comes to business where appropriate use case for Canary style deployments, and that's where the business rules, they don't change. So when I was working at DTN, a lot of our core processes were handled by Oracle packages. And if you've never dealt with Oracle packages or put a tremendous amount of business logic in Oracle packages, just know that you've dodged a big bullet because they are very complex. And when you add a lot of business logic in there, it gets even more complex. And so I was tasked with rewriting one of the core services and taking all of that logic out of the Oracle packages and putting it into a .NET service. The mandate I was given is you had to make sure that if I sent through a request through the Oracle packages or the .NET service, the response would be the exact same. And so what I did is I put together all these Visio documents to make sure I understood all the business rules, unit tests, integration tests. I was going through and I was looking at the previous day's requests that were coming through and responses and making sure everything was matching up, trying every possible thing I could think of. And when something didn't match up, I was responsible for making sure that it did match up. And I actually found bugs in the Oracle packages, but I couldn't fix the bugs in those packages. I had to insert shims into my .NET service to make sure that the responses were the same. And so when we did our rollout, we only redirected like 2% of the traffic for the very first night. And this was just to make sure that everything was working as we expect. And then the next day, we maybe increased it up to like 5 or 6% or something like that. And then the weekend came, and then we moved it back down to 0% because we didn't want to be bothered on the weekend. And then the next week started, and then we increased it back up to 10%, and then 15%, and 20%, and so on and so forth. And so the actual rollout took multiple days, but it was an appropriate use case for Canary style deployment because I could route traffic to either version, and I know I'd get the exact same response. But when you indiscriminately route a percentage of your traffic for new functionality or a new user interface, you can lead to a very disjointed user experience. So I want to use a real world example for this. Let's talk about the Octopus Deploy user interface. At the very start of the year, this was the Octopus Deploy dashboard that everyone was used to. And then for our Octopus Cloud customers, somewhere around, I would say, June, July, August, depending on when we rolled it out for your particular instance, the dashboard changed to this. Now imagine a scenario where you were indiscriminately routed. So 1 minute you might get this, and then 2 minutes later, you get this user interface. And then 5 minutes later, you get this user interface. And then another 5 minutes later or 10 minutes later, you get this user interface. And this is assuming that you get all the JavaScript files, the CSS files, and the images, so it can actually show you correctly. Chances are you might end up in a situation where you get a half-page load or something like that. But could you imagine what that user experience would be like? It'd be very, very frustrating. So this is probably where you're probably saying, Bob, this is where session affinity or sticky sessions can help. You're right, except we have situations where users, they leverage multiple devices. So I have an iPad and I have a laptop and I have browsers on both. I have an expectation that when I go to a specific website that I'm going to get a similar user interface because essentially they're both laptops when it's all said and done. Or you can end up in a situation where, like I had with when I was working at DTN with that service, where rollouts they lasted longer than the actual session duration. I mean, this was multiple weeks when it's all said and done. Or you want to be able to target a specific group of users. Maybe it's an internal application and you added new functionality for a team, and you want to make sure that's going to work for that particular team before you release it to everybody else. Or you're deploying to the edge and you want to make sure that everyone's at a particular retail location or a factory or a branch or a bank. They all get the same functionality. There's also situations where you have business rule coupling. So when I was working at a bank, I was responsible for the loan origination system. And it called out to a whole range of different services. So we had a customer service, we had a financial service, we had a collateral service, we had a credit check service. They were all independently deployable. But the business would come through and they would make a business rule change. And every one of those services, including my application, we'd have to modify to on our own way to meet that business rule. And so if I'm on a new version of the loan origination system, I make a request, I want to make sure that that business rule is applied for my request through all of those services. I don't want indiscriminate routing, maybe going to the old version, using the older business rule. So this then asks the question, does Canary deployment solve all the user requirements? And the simple truth of the matter is no. It can help solve some of the requirements, but when we start scratching at the surface, it doesn't solve for all of the requirements. And I think this is the reason why I don't see Canary deployments be very, very popular across a whole host of applications. It's typically applications that meet a certain specific set of requirements. Another unfortunate truth is that there's this belief that you'll be able to find bugs with Canary style deployments before it reaches out to the entire wider audience. But unless you're working for a FANG-sized company, you're going to be very unlikely to exercise all the code paths in a short period of time. So a Canary style deployment, when you boil it down, it's useful for verifying the new version works and can pass some simple verification tests, but it's not going to solve everything. So let's talk about some progressive strategies that you can implement today. So there are 3 progressive strategies that I want to talk about. I've already talked about traffic-based routing, but I've been primarily focused in on the Canary style approach. I also want to talk about blue-green as well as the staging pattern. I also going to talk about, in terms of another strategy, feature flags or release toggles. And then finally, I'm going to talk about tentative release rings. So let's first talk a little bit more about the traffic-based routing and just the core concepts of this. So really what we're trying to do here is we want to leverage a load balancer to route traffic to a particular version. So we're going to have multiple versions in production. With a blue-green pattern or a staging pattern, what you're doing is you're deploying a new version of your code in production to a place where your users can't access it. But internally, maybe developers and QA people, they can access it. And this allows you to verify prior to letting all of your other users access that new version of your application, because they're still on the previous version of your application. And one of the advantages of this is that verification that can take as long as you want it to take. I've done the staging deployment pattern like this, where we pushed out a new version of the code, say at 11 a.m., and then we didn't redirect all the user traffic until off hours, so it was about 7:30 p.m. So from 11 a.m. to about 5 p.m., we're performing verification, we're making sure everything's working as we expect. And so when we actually made the switch, it was so seamless that no one noticed, because we had a high degree of confidence that we knew it was going to work. And so that's the idea. Post verification, you route to a new version of the application. Now, the difference in my mind between blue-green and a staging pattern is a blue-green style deployment is that previous version it's going to remain available for a substantial period of time, typically until the next deployment, because you have maybe two sets of the environment, like two environments or two application hosts, one blue, one green. Whereas a staging pattern, the previous version is deleted after a short period of time, maybe a couple seconds, maybe a couple minutes, maybe an hour. But at some point, something comes through and cleans up that previous version pretty quickly. Now I want to talk a little bit about feature flags. I think there's some misconceptions with feature flags. The goal of a feature flag is you want to separate the deployment of a new version of your application from releasing new functionality to your users. That is the ultimate goal of a feature flag. But all too often, feature flags are seen as binary, meaning they're on for everyone or they're off for everyone. So most feature flag implementations that I've seen is they have a value in a configuration file, and it's either a 0 or it's a 1. And so when they want to enable it, they change the configuration file to a 1 for a particular environment. They go, oh, now I have feature flagging. In reality, modern feature flagging is much more nuanced. So with modern feature flags, what you do is you create segments of users, however you want to define those segments. So it could be based on, like, say, location or a team or usage history or deployment environment that you're going to, or users can even sign up and say, hey, I want to be part of the beta. And when you do a deployment with these feature flags, especially that initial deployment, you deploy with everything turned off. That way you know it's going to work if you do have to turn off the feature flag later. And then after you do that initial deployment, verify everything works with it turned off, then you turn it on for the smallest group, your dev and QA folks. And this is for verification and testing. That way you can verify the new functionality is going to work. And then assuming that verification passes, then you increase it to your early adopters. And this is where you could have users that can opt in or they can be assigned, however you want to define your early adopters. The beauty of this is that if a problem is discovered, you just stop progressing. You don't have to continue to enable that feature flag. And if required, you can actually turn it off. So going back to the Octopus Deploy user interface, when we released it to all of our Octopus Cloud customers, there were a couple that were blocked. And so what we did is we just went in and turned it off for them so we can get them unblocked. Then we fixed the bug, pushed up the change, and then turned it back on after notifying them, obviously. So that allowed us to get this very fine-grained control. And the idea is that we can enable this over a period of time. It can be enabled after a couple of days, a couple of hours. Again, going back to that Octopus Deploy, the new dashboard or the new user interface, believe it or not, that functionality was embedded within Octopus Deploy. That new user interface was embedded within Octopus Deploy at pretty much the beginning part of this year. So that was crazy to think about. And so I had access to that user interface for so long, I almost forgot what the old one looked like. And then when I did go see the older version, the older user interface, I was like, oh, wow, this is rough. So again, we can enable this over a period of time. And then we go from 33% up to 66%, and then eventually 100% of all users. Now, what's really powerful about this approach is that you can get progressive delivery without adopting a blue, green, or canary style deployment where you have to change a bunch of additional things. And I'm going to get into a lot of the things you're going to have to change in just a couple minutes. Another big benefit is you can help prevent big bang merges. So if you're a longtime user of Octopus Deploy, you're probably familiar with the Spaces feature. Well, the Spaces feature branch, that was a long living feature branch that lasted for months upon months. And then when we did the big merge, it was like mixing Mentos and Coca-Cola. But when we look at the new user interface, we were constantly merging into main over and over and over again because it was hidden behind a feature flag. And that allowed us to push out that functionality and have it be dog-fooded, internally tested on the same piece of code as what was in production today. And so it helps prevent those big bang merges because you can have functionality hidden behind the feature flags. And this is why feature flags are on our roadmap, is because we believe this is one of the crucial pieces for progressive delivery. Now I want to move on to tenanted release rings. Now, when I start explaining this, deployments are going to look very similar to feature flag segments. So I'm going to breeze through it pretty quickly, but the core concept is still applicable. So what I have here is I have a map of Omaha, and I have 6 locations that I want to deploy to. So the tentative release rings is ideal when you have multiple locations and each location needs to run a dedicated copy of your application. This concept that I'm about to discuss, this also applies to SaaS companies who host a unique copy for each of their customers. So I'll use Octopus Cloud as an example. Every single customer, they get a dedicated instance of Octopus Deploy. They get a dedicated copy of the application. And so when we want to do a deployment, we'll first deploy to, say, an alpha location or an alpha customer. And then we'll verify. We'll make sure that everything's working as we expect. We're not hearing any problems. And then assuming that everything's working as expected, then we can deploy to beta locations. And just like with feature flags, if a problem is discovered, we stop rolling out to other customers and locations. But then assuming everything is working as we expect, we can deploy to remaining locations. So if you've used multi-tenancy functionality within Octopus Deploy, you're probably very familiar with tenanted tags and one of the things we use tenant tags for are release rings. So I have a screenshot showing an example of what that would look like. So fun fact, you can actually combine multiple approaches. You're not limited to just one. So internally at Octopus Cloud, we have isolated infrastructure for every customer, but we combine the tenanted release rings with feature flags. So we will pick a subset of customers that we'll deploy to. Typically, what we first deploy to is what we call our deploy instance and all of our staff instances. They get the latest version. And then we'll start picking a subset of those customers after the fact, and then they'll get the new version. And then we'll continue to release out over and over again. One of the things we built internally was basically what we call it the and-on cord. And if you're not familiar with that term, that comes from Toyota's assembly line. And the idea is to be able to stop the assembly line and make sure that a small problem doesn't become a big problem that ends up in a recall. Well, with Octopus Cloud, the and-on cord just stops updating all of the instances. But that gets the new version of the code out to our customers. Now, when it comes to new functionality, this is where we use feature flags. So all the new features are turned off by default for all of our cloud customers. We'll first turn them on for staff instances once we reach an appropriate point when we feel confident that, yes, this is something that we want all of our staff people to start using right now. Then assuming that works successfully, then we'll slowly roll it out for general adoption. And before we push it out for our self-hosted customers, we'll typically go in and we'll remove those feature flags from the self-hosted releases. So now I want to spend the rest of the time talking about process changes that you're going to have to make. And truth be told, it's more than just changing how you deploy your code. It's going to change how you make changes to your code. So for using some sort of traffic-based routing, you need to have the ability to update a load balancer or an ingress controller to appropriate route traffic for you. Because ultimately you need to be able to support multiple versions in production. The good news is, depending on the application host, that functionality is already built in. So if you look at native Kubernetes as well as Azure Web Apps, they are very close to that staging deployment pattern. In fact, they call it a staging slot for Azure. And then for native Kubernetes, with every time you push out a new version, it creates a new replica set, and then it will eventually destroy the old replica set. If you want more of a Canary style or maybe a blue-green style deployment, if you're on AWS Lambdas, that functionality is built in. And if you're on Kubernetes, this is where something like Argo Rollouts can help you out. The big thing I would recommend here is don't go against the grain. So for example, if you're on Azure Web Apps and they have the staging slot, use the staging slot. Don't try to come up with some new fancy way to do it. Use all that pre-built functionality. But one of the big challenges that you're going to face is you're going to have multiple versions running in production. And so many applications today still rely on a relational database. Now, I've read a number of different articles and I've also listened to some recommendations. And one of the thoughts is, well, what you can do is you can just clone that database so you have two production versions. That way you can have true blue-green deployments or Canary style deployments. I do not recommend that at all. In fact, I hate that idea. You need to avoid having multiple databases because what you're going to end up with is a split brain scenario where you have two databases that think they're the truth center and you'll need a mechanism to be able to reconcile any sort of data differences. And then, so you're going to spend more time on reconciliation than it would be to just have a single database and adopt the expand and contract pattern. So let's pretend that you're working on an application, and in that application, you have an account table and it has a zip code column. And that application has only been used in the United States because all of our zip codes are numeric. But now you want to go and you want to expand to international. Well, they use postal codes. And so there's alphanumeric that you need to consider. Now, in the past, what you would do is you would just change the type to alphanumeric from numeric, and you probably would change the name. And then you have to go in and you change your code and you deploy all of that at the same time. Well, if you did that, you can't have multiple versions of your application running in production because your database changes are not backwards compatible. Instead, what you need to do is you need to make a series of very small deployments. The first one adds the postal code to the account table. That way you can always roll back. It's very easy to roll back because no one's using that postal code. The next thing you'll need to do is have another deployment where you go in and you update the code to read and write to both columns. And you need to have some sort of reconciliation within your application to be able to handle differences where the postal code and the zip code are different. But for the most part, they should be the same. And if you have to roll back, again, it's not that end of the world because the previous code only wrote to the zip code column. And then weeks later, you'll need to go in and you need to remove the code that writes to zip code. Again, if you need to roll back, that's fine because you had previous code that was reading and writing to both columns, except unless it's alphanumeric that only writes to postal code. And then finally, after you remove all of the code that references zip code, then you can go in to the database and have another deployment that removes zip code from the account table. And again, if you need to roll back, it's not the end of the world because none of your code still references zip code. So very, very disciplined, and everyone on your team has to buy into this approach. For feature flags and toggles, one of the things I like is Open Feature. It's a CNCF project, and it offers a variety of different providers, including Launch Darkly. It also speaks whatever language you want. It has providers for pretty much every popular language that's out there. Now, the one thing to kind of keep in mind is that some feature flags, they're going to live for quite a significant amount of time. For example, if you are a SaaS provider and you offer different entitlements based on what they purchased, or there's different permissions. Those are some examples of different toggles versus, say, just release toggles where you have a different version of your code. But I want to point out that feature flags, they also require the expand and contract pattern because you need to go in and you need to delete those feature flags if they're not being used anymore. One of the key things to remember is that progressive strategies is going to require a significant investment in your time to properly adopt. But there are successful ways to adopt it. And these strategies I showed you are what I've witnessed to be very successful that gets you, I would say 95% of the way there for all of the business and user requirements. In terms of my order of precedence for implementing what I call permanent strategies, these are things that you're going to operationalize and be part of your SDLC, part of your deployments that are going to be permanent. I would look at feature toggles. And then depending on your application, look at the blue-green or staging pattern. If you solve for that, moving to Canary is going to be much, much easier. Or consider tentative release rings where it doesn't make sense to have a blue-green or staging pattern. Again, it depends on your application. Shameless self-promotion. I wrote a white paper about all of this. Go to octopus.com/whitepapers. And that is it. Thank you very much for your time.